Dynamic memory allocation. Now there are two types of memory allocation in C. One is static, one is dynamic. Static is nothing but once you allocate the memory, you do it even before you know how much of memory is actually required. If you say integer, you are just giving them 2 bytes. If you say double, you are just giving them 8 bytes. You actually never know whether really those 8 bytes are used at all ever in your program. But it is simply allocated and it remains like that. Neither is it being used by that variable, neither is it available for other variables to use it. So when you are using a large program or running a large program and a large amount of memory is required, such wastage of allocation is not advisable. You need to have a large amount of memory for you to run your program. So in such cases, there is a concept called dynamic memory allocation where at the execution time, during runtime we call it, the amount of memory that is explicitly required for that particular application alone is given to that particular variable, and once its execution is over, you can release that memory back to the memory space. So that is the concept of dynamic memory allocation. Static is it is already done and it remains the same. Dynamic is at execution time when you are running the program, you allocate the memory based on the requirement. So the process by which required memory address is obtained without any explicit declaration. Explicitly you do not declare that you have to allocate so many bytes. According to the requirement, memory is automatically allocated. Here you have certain functions which are predefined. Using those predefined functions only you are going to allocate the memory. It returns a pointer to the block of memory of requested size. So how is the memory allocated? Using a pointer variable. When you are using the memory allocation function to assign memory to a variable, it returns a pointer holding the address of the first block of memory. And these functions are included in the header file stdlib.h, that stands for standard library. So like in normal C programs we use stdio.h. When you are using the dynamic memory allocation, all your programs should have the header file stdlib.h. So these are the memory allocation functions. In that malloc, calloc and realloc are used for allocating the memory. Free is used for releasing the memory. So now we will see how each of these work. All of them allocate the memory, but the thing is they do it slightly differently. Malloc allocates a single block of memory to store values of specific data type. So this is something like a union where it stores a single large block of memory for a specific data type. So it can only store either for integer or for float or for double or for character at a time, and it stores and it just allocates one block. The syntax for this is, as I said, it returns a pointer value, so it has to be collected by a pointer variable. Type star, whatever type, integer or float, followed by the dereference operator or indirection operator. Malloc is a function, within brackets the size. So this is an example, integer pointer variable, that pointer is equal to the pointer type followed by the indirection operator within brackets, followed by the memory allocation function malloc, followed by the size. If you do not want to explicitly mention the size as 20 or 40, the second example can be followed, like how many variables of type integer. So the same concept is used, only thing within brackets you tell the data type plus the number of variables of the data type. So if there are 10 variables, 10 into size of int. So instead of you calculating the total amount of bytes, a compiler will calculate it and it will allocate the memory. So both ways you can allocate memory for this malloc function. So malloc is nothing but allocating memory for a specific data type, and this is the syntax. Now calloc function works slightly differently. This also allocates memory but in multiple blocks of the same size. So in malloc it allocates one full block for the maximum size. This allocates multiple blocks of the same size. So instead of allocating 20 blocks as such, it is not identified by the pointer as one continuous block of 20 bytes. It is identified by the compiler as 4 blocks of 5 bytes each or 5 blocks of 4 bytes each, which totals up to 20, but each block is identified individually. It assigns the address of the first byte of the allocated area to the pointer. So though 20 bytes are allocated, the first byte of the first block of the memory only the pointer holds the address, and they will be continuously stored in memory. The same syntax, only thing instead of malloc you use the calloc function here, and within CAlloc you are having two arguments. One is n, which shows the number of blocks to be allocated, and m is the memory size of each block. As I said, it can be 5 blocks of 4 bytes or 4 blocks of 5 bytes. So n determines the number of blocks, m determines the size of each block. Example, float pointer variable. So this also stores the variable stores the memory only for a particular data type, which you have to explicitly mention. Pointer float indirection operator, CAlloc 20, 4. So what is 20? 20 is nothing but the number of blocks. 4 is nothing but the size of each block. So 20 into 4, totally 80 bytes of memory are allocated. Another option here is again CAlloc 20. 20 is the number of blocks into size of float. This is similar to the malloc function, where instead of you yourself telling the size of a data type, you allow the compiler to decide it. So this is how it is stored in the memory and it is identified by the memory. This pointer variable holds the starting address of the first block. The starting address of the block is 200, so that is held by the pointer variable. And then each block of memory is of the size 4. That is why 200 to 204, 208, 212 and so on, up to 20 bytes each. So totally 80 bytes are there, so up to 276 you store the values. This is how using a CAlloc function the memory is allocated. Realloc is nothing but reallocation of memory. So malloc and CAlloc are used for initial or the first time allocation of memory to variables, whereas realloc is used for already memory is allocated, but you want to make some modifications in that, you want to reallocate that memory from the existing memory space to somewhere else in the memory where it is free. So this modifies or reallocates the memory space previously allotted. It is also called reallocation of memory, that is a short form of realloc. The syntax, the same syntax here, pointer variable is equal to realloc, but within brackets again you are having two arguments. One is a pointer variable itself. Why? Because you should know where the previously allocated memory is existing, and next the size, how much of memory is to be reallocated. So the example here, integer pointer variable p is equal to the data type malloc 50, that is, it is showing that this is already allocated memory. So using malloc you are allocating some memory and storing it in the pointer p. And next, using the realloc function you are getting the first allocated address which is stored in this variable p. And earlier 50 bytes were allocated, now you are going to allocate 100 bytes and again store it in the same pointer variable. So this is just an example where already allocated memory is being reallocated using the realloc function. Earlier 50 bytes were allocated, now 100, and the size or the pointer where the first allocation was done, that is also held over here. The new allocation is also stored back in the same pointer variable. So this is the concept of the realloc function. So next we move to free. Free is nothing but release of the memory. So this releases the memory space that is allocated using any one of the memory allocation functions. Now you should remember that memory that is allocated using the dynamic memory allocation functions only can be freed by this free function. The syntax is just free and the pointer variable that holds the address.